And finally, in section D, students find that the factored form is useful for finding the vertex of the graph because its x-coordinate is halfway between the points where the graph crosses the x-axis, or the roots, or the x-intercepts, all of those terms. In other words, these lessons use the symmetric attribute of parabolas to teach students how to determine other attributes of the quadratic function given in factored form. Now, as for the standard form, students investigate the coefficients of the quadratic and linear terms further. They notice that the coefficient of the quadratic term, or a, determines if the parabola opens upward or downward. They also realize that the coefficient of the linear term, b, is somewhat mysterious and more complicated. Students explore how it shifts the graph both vertically and horizontally in this optional lesson. It really sets them up for the following lessons, where they start to investigate the vertex form of a quadratic function and understand how the parameters in the vertex form influence the graph. They not only learn how to determine the vertex from the vertex form of the function, but they also begin to relate the different parameters in the vertex form to the general ideas of horizontal and vertical translation, vertical stretch, and other ideas that will be investigated in a later course. This section is using student understanding about key components of quadratic graphs, such as symmetry and zeros, to identify transformations. In this way, students move from 7a and 6b into 7c. Now, recall that 7c is a readiness standard that focuses on transformations, and it's the basis of so much of Algebra 2. It's really the foundation upon which the study of function families rests. But also note that the transformation parameters a, b, c, and d are used differently than a, b, c in the standard form of a quadratic. For instance, the vertical shift is represented by c in one form and by d in the other form. This may pose confusion for some students. Now, within this section, I really want to highlight two specific activities in Lesson 12. In one of the activities, students really get to play with the calculator to investigate the transformations. In using the questions as guides, students are able to describe what each of the transformation parameters do without us telling them. Then in the next activity, they participate in a card sort to practice using their knowledge. I highly recommend using anchor charts for these lessons. And if possible, let students make their own anchor charts. In fact, I love having students participate in what I call an anchor chart pageant or a competition. To do this, provide students with the three forms of the quadratic functions and a word bank. Ask them to create their own personal anchor chart as an individual. Next, have groups of 3 to 4 students merge their anchor charts into one version that they're going to present to the class. Have the class vote on the best anchor chart from all of the groups and discuss why it is the best. This class winner will be the one that represents them in the anchor chart finals. The next day, show the anchor charts from each of the class periods and have students vote on the one they would like to have displayed in the classroom. This is the final round. You repeat that for each class period, and the final winner from that day will be the anchor chart champions, and they're going to post that chart to use for your review all the way until STAR. You may even want to allow some time for students to revise their own personal anchor charts that they can keep with them and take home. This process encourages students to reflect on the information at least 4 times, personally, with a group, when they vote for the class winner, and then again when they vote on the overall winner.